But first, these are operators. They're not, well, I don't know the math lingo, but you can't do that. Okay? It's like square root. Can I do that? Can we quickly prove that that can't happen? Something quick. I'm recording this, so are you going to interrupt me? Okay. So you can't do that because this, is 2, and that, is 3, which makes 5, and that's definitely not the same thing as root 13. You can't join them together. We did radicals, okay? This is the same thing. Don't try to distribute sine over 2 things in the brackets there. You can quickly prove that to yourself as well. You got a calculator? Okay, you will see these are not the same. So I don't really like showing you what you can't do because some people, now that you've seen it, you think, hey, I saw that, I can do it. Subconsciously, you're visual, right? But it's there, it's in the notes, and anyway, don't do it. That's all I'm saying. No. Okay? So, there's an identity for sine when you can add a couple of things together in brackets. And here's one for sine when you subtract a couple of values in brackets. And then we got a couple for cosine, and then we have a couple for tangent. And there was not much I remember from high school, but I actually do remember doing these ones. I don't know what it is. Then again, maybe it was first year university. I don't know. I just remember doing it. Okay, so you might accidentally memorize these, but you don't have to. Okay, I'm going to give that to you. But you need to know, looking back and forth, which one to use, obviously, and obviously you need to not make a mistake. So, evaluate a special triangle that isn't a special triangle. Could I break this thing up into some things that you guys are supposed to know? Like, pi over 12 would be the same as 4 pi over 12 minus 3 pi over 12. We all agree? Okay, well that's pi over 3, and that's pi over 4. And do we remember what sine pi over 3 is? That's going to be a 1, that's going to be a 2, so that will be a root 3. That's 60, that's 30, otherwise known as pi over 3, pi over 6. Remember that stuff? You remember if we got this thing, isosceles triangle, and then that's a 45, and then that would be, that would be a root 2. Okay, so sine of pi over 3 is O over H, and sine of pi over 4 is O also over H, okay? A little bit of review. Hey, your test is in 3 weeks, right? Okay, so what can I do with that? I can do that. No, sorry. I can do that one. Okay? So this is the same as sine of A. A is the first thing in the brackets here. Times cosine of B. B is the second thing in the brackets. Minus, okay, because that's in this form, cosine of A times sine of B. Okay? And then what's sine of pi over 3? Root 3 over 2. Cosine of pi over 4 is 1 over root 2 minus cosine of pi over 3 is 1/2 times sine of pi over 4. It's the same as cosine pi over 4. Okay, what's this? Root 3 over 2 root 2 minus 1 times 1 is 1 over 2 root 2. Do I need a common denominator to subtract fractions? Yes, and I do. So I can just go root 3 minus 1 all over 2 root 2. And that's as clean as I'm going to keep that one. Okay, I could rationalize the denominator, but in this case, why bother? Okay, I don't think it's going to make it any nicer. Okay, I evaluated sine of pi over 12. Would I be able to check that on my calculator, do you think? That should make the same decimal as this, and it does. Don't believe me? Do it yourself. Should I do it? You believe me? I should do it? Well, if that's a pi, radians. And if this, of course, is just numbers, it's not going to matter, right? So this one is in radians. Sine pi over 12 is 0.2588. And what is this? Square root of 3 minus 1 equals divided by 2. How do I put this in? What do I do next? Times or divide? Yes. Everybody wants to put in 2 root 2. It'll times root 2 up there if you do that, okay? Don't do that. Divided by root 2. Hey, look, got the same thing, 0.2588. Okay? Voila, it works. 10 pi over 12 is the same difference of fractions. Okay? This isn't one I recall using, but we got it now. So I've got tangent of some angle minus some angle. So I'm going to use this identity and write it as tan of A minus tan B. What's going on with my hand today? All over 1 plus tan A times tan B. Okay? Tangent. That's the weird one. Even I need to look that up sometimes. I don't have that memorized. Tangent of this is O over A. So that's just root 3. Minus tangent of pi over 4. Tangent of 45 degrees. O over A. That's 1. All over 1 plus, I already got that. I already got that. Okay, so all I would do to rewrite that, since I'm running out of room, is just not worry about that 1 down there, because root 3 times 1 is just root 3. Okay, that's what it is. And then we can do questions like this. Does that look familiar? We've done it. Chapter 4. Cosine of A is this, and A is in quadrant 3, down here. And tan B is negative 5/12, and B is in quadrant 2. Okay, there's A. There's B. I got 2 things going on. Find the value of that. Well, what is that? Let's have a look. Cosine of A plus B is cos A cos B minus sine A sine B. Okay, that you don't need to know. You look it up on your little chart of identities. But in order to evaluate this, I need to know what cos A is. Well, I already got that. But I need to know what cos B is, and then I need to know sine A and sine B. Okay? So let's start with A. If cosine of A is negative 3/5, well then that means that's a negative 3, and that's a 5. Which must mean, y'all got this memorized, or would you try to figure this out? 5 squared minus negative 3 squared, that's 4, right? And I also know it's a negative 4 because in that quadrant, obviously y is negative. Okay? So I need to know sine A. Sine A is O over H, or negative 4/5. Okay? So cosine A is negative 3/5 times cosine of B. Oh, I need cosine B. I do know for this triangle, tangent is negative 5/12, and it's in quadrant 2. So negative 5 for tangent for this angle is, sorry, that's over there, O over A. The negative must be on the 12. Okay? Do we have this triangle memorized? What's the hypotenuse here? What is 5 squared and 12 squared? What's 25 and 144? 169. What's the square root of 169? Yeah. Okay. It's a nice triangle. We're not trying to kill you here. Maybe. So sine of A, I already got. I'm going to need sine of B, and I also need cosine of B. So let's start with sine. Sine of B is 5/13. And cosine of B is negative 12/13. So I don't need to say something like, if you make a mistake on this triangle, the whole rest of the question is junk, right? So don't. Okay, this is the easy stuff. This is like a 3 or 4 mark question. Cosine of B. Everybody happy with that? I didn't make a mistake? We're all good? Okay. A lot more eyes than mine on here. Okay. So that's cos A. I already got it up here. Times cos B minus sine of A is negative 4/5 times sine of B, which is 5/13. Now we're back to a hard grade 7 question. Fractions. Everybody's favorite, right? Negative times a negative is a positive 36 over, what's 5 times 13? 65. Negative times a negative, that's going to be a positive. 4 times 5 is 20 over 5 times 13, 65. So 36 and 20, I got the same denominator. That's 56 65ths. Okay? So I've already got the same triangles. Now I need tangent A plus B. What's that? Tan A plus tan B. Over 1 minus tan, what? Tan A, tan B? So, tangents I need. Well, I know tan B, but I don't know tan A. What's tan A? Negative 4 divided by negative 3, or positive 4/3. Does that make sense? Is tangent positive in quadrant 3? Use your cast? Yeah, it should be. Okay. Always double check a lot of this stuff. So tan A plus tan B all over 1 minus tan A times tan B. It's ugly fraction stuff. But being in Math 12 pre-calculus, I think we kind of expect you to do this properly. Kind of. I got to add these two fractions here, so let's make that a 12. 3 goes in there 4 times. That's 16 twelfths minus 5 twelfths is 11 twelfths over 1, let's do it that way, minus negative 20 over 36. So that's 11 twelfths over 1 plus 20 36ths, which is 36 36ths plus 20 36ths is 56 36ths. Do we know how to divide fractions? No. But I know how to flip it and multiply it. Having fun yet? 11 twelfths times 36 56. And I think I can reduce that before I throw that in my calculator and multiply it. Right, Brooke? 12 goes into itself once. 12 goes in there 3 times. 33 56s. Okay? It's always the fractions, right? It's the worst part. 2 or 3 more. Questions? Kind of done half of that before. Now we're just adding in the identities, right? Simplify. What if we give you that identity and say simplify it? Do you want to write it like that? What is that? Cosine A plus B? No. That might be cosine of A minus B. Okay. Cos A cos B plus sine A sine B. Cos A cos B plus sine A sine B. So that is the same as cosine of A, was it minus? Forgot. Yes. Okay, well A is 6x and B is 2x. What's 6x take away 2x? All that's the same as cosine 4x. I would say that's simplified. More importantly, I answered the question. That's a single trigonometric function. Okay? Simplify. Cos A minus B. I just did that one, right? Okay, so that's the same as cosine A times cosine B plus sine A times sine B. Here A is pi and B is x. So cosine pi cosine x plus sine pi sine x. We shouldn't need to put these in our calculators. Start at 0, pi over 2, pi, 3 over 2 pi, and I go over here to 2 pi. What do I know about cosine pi? Remember from my unit circle, cosine is the x part. Here, x is a maximum, which means for a unit circle, it would start at positive 1. Here, cosine is 0, because there is no x component vertically. Over here, what is x? It's negative 1, right? Now, having said that, Oh, look, I'm right. That's -1 cosine x. Sine of pi. Sine is the y component. It starts at nothing and then gets bigger and bigger and bigger until it's a maximum 1. And then it gets smaller and smaller and smaller until what is sine of pi? How big is my... Whoa. How big is my opposite over here? There isn't one. Right? What's anything times 0? That's negative cosine x. Tan pi plus x is tan A plus tan B over 1 minus tan A, tan B. So tan A plus tan B over 1 minus tan A times tan B. What's tangent of pi? Well, tangent is what over what? Sine over cosine. What was sine pi? What's 0 divided by anything? Put it in your calculator if you don't believe me. What's tan of pi? Tan x. Okay. Last one. By the way, tomorrow's lesson is flipping huge. Just to let you know. I might break it in two, but I haven't decided yet. Be prepared if I don't. Okay, last one. Sine pi over 4 plus theta plus sine over that minus theta. Prove. It means it is equal. We got to prove it. Does this look like an identity on the left here? Is that this one? That's just sine A plus B. Okay, there's a plus here. So that's the same as sine A plus B. But does that help me? No, I'm going backwards. I don't care. You want the long answer or the short answer? Something did fluke up. Okay. What do I do with that? That is sine that plus that. Sine pi over 4, sorry? Cosine theta, okay, plus sine, cosine. Let's go look again. I did it. I didn't got it. Sine, cosine, cosine, sine. Just for consistency's sake. You know, it doesn't matter, but let's write it the way it is. You just got to make sure you don't make a mistake. Like me. Okay? All of that is this, right? That's the identity. Here's another one. So, how about purpley? That's sine A minus B, which is sine A cosine B minus cosine A sine B. Okay, all of that's the left side. This I'm going to kind of leave alone, right? It looks, what can I do with root 2 cos theta? So I want the left side to look like that. Okay, sine of pi over 4 is what? Okay, thanks. 1 over root 2. What's cosine theta? Well, I don't know. It's cosine theta. Cosine pi over 4 is same thing. Sine pi over 4, I already did it. 1 root 2 cos theta minus 1 over root 2 sine theta. What can I do now? Collect some stuff. Anything the same there? How many 1 over root 2 cosine thetas do I have? All right. I have 2 1 over root 2 cosine thetas. And how many 1/2 sine thetas do I have? I got one there. And then I'm going to take it away. Yeah. Okay. So I have 2 of those. In other words, I got 2 over root 2 cosine theta. Is that the same as that? What? Can I do this? Yeah. So root 2 times root 2? Yeah, that is the same. Okay. Not so bad. Quadraten stratum. Okay. More fun stuff.